Hi everyone. Today we are going to discuss turbines, which is of Unit 5. After this session, you will be able to know what is a turbine and the classifications of turbine. So first, what is a turbine? Is a turbine a rotary mechanical device that extracts energy from fast moving flow of water, either steam, gas, or other fluid which converts into useful work. A turbine is a turbo machine with at least one moving part called as a rotor assembly with a shaft or drums with blades attached, like this we shown in the diagram. This is the rotor part. And moving fluids act on the blade so that the moving and impart the rotational energy to the rotor. The turbine, the main definition of the turbine is which is used to convert the hydraulic energy to the electrical energy, where the turbine shaft is directly coupled to an electrical energy generator, so that mechanical energy is converted into the electrical energy. And the electrical power which is generated through these turbines is known as hydroelectric power if the water is sources. And the types of turbines are water turbine and the subclassified as impulse and reaction turbines, steam turbines, gas turbines, and wind turbines. Based upon the use liquid will be classified as water turbines, steam turbines, or gas turbines. All the same principles of all apply to all the turbines. Their specific designs differ sufficiently to merit separate descriptions. So first we shall go with the impulse turbine. The fluid is forced to hit the turbine at high speed, and the impulse turbine, the water is directly heated to the buckets, and this is a stationary nozzle, and the carved shapes are known as the buckets. And the best example for the impulse turbines are Pelton wheel turbine and the cross flow turbines. So this is a schematic diagram of a Pelton wheel turbine. And the next is cross flow turbines. In a cross flow turbines, the water is admitted to the turbine edge, and after water passing through the runner, it leaves in opposite directions, which we can see. The water is entering in this direction, but the leaving is in opposite direction. These are for low speed machine that is suited for locations with low head but high flow is required. And next is reaction turbines. In reaction turbines, we can see both the pressure energy and the kinetic energy. So which is given in this like this. In the reaction turbine, the forces driving the rotor are achieved by the reaction of an accelerating water flow in the runner while the pressure drops. In reaction turbines, torque developed by reacting the fluid's pressure. The pressure of the fluid changes its passes through the turbine rotor blades. And the classifications of reaction turbine are Kaplan turbine, Francis turbine, and kinetic turbine. So first we shall discuss about a Kaplan turbine. A Kaplan turbine is a water turbine which has adjustable blades and is used for low heads and high discharge, where the head of the liquid is low, to be discharged is low, and so where the head is, height of the storage is low and the discharge should be high required, we will be using this Kaplan turbine. So this is a schematic diagram of Kaplan turbine. And this turbine is having an inward flow reaction turbine, which means the working fluid changes the pressure as it moves through the turbine and gives it to the energy. And next is a Francis turbine. Is a type of turbine which are used to medium heads and medium discharges. It is a type of reaction turbine, a category of turbine in which the working fluid comes to the turbine under immense pressure and the energy extracted in the turbine blades from the working fluid. And the next is kinetic turbine. When the name itself is also called as free flow turbine, which is used to generate electricity from the kinetic energy in flowing water. The systems may operate in rivers, man-made channels, ocean currents. Used to utilize the water streams in the natural pathway. So now we'll go with Pelton wheel turbine. So this is the Pelton wheel schematic diagram structure, which was named after Laston A. Pelton, who developed the Pelton wheel turbine in the year 1880. It is a tangential impulse turbine where the available energy is completely at the entrance and the kinetic energy is preferred very high heads and low discharges. It is used for with operating heads of 15 to 1800 meters. Although there is no theoretical limit, and it consists of parts penstock, nozzle, spare, and wheel, tailstock, casing, runner, pitch circle. The components are nozzle with guided mechanism. The function of nozzle of a Pelton wheel is to convert the available pressure energy into high velocity energy in the form of a Z. The quantity of water required is proportional to the load on turbine. Therefore, to control the flow of the nozzle, some sort of regulating valve will be governing mechanism is used. The nozzle is usually made of either cast iron or cast steel. And this is the wheel of the turbine, which consists of runner with buckets. The runner of Pelton wheel consists of double cupped buckets with an angle of 135 degrees fixed to the periphery of the wheel. Each bucket has sharp edge at the center, which is called as a splitter. A splitter takes the full impact of the set, so quite strong. This is the construction diagram. And next we will be using the casing. It is made of cast iron, which is used to not to perform any hydraulic function, and the casing is necessary to avoid accident splashing of water to let the tail race. And the dimensions of bucket, the maximum width of the bucket is taken as 2 times the diameter of the wheel of the Z, and the dimension of the usual is 2.8 to 3.8, and the depth is taken as 0.8 to 1.2 diameters of Z. The head is taken as height 2.4 to 2.8. And usually we'll taking the number of Z's as 4, but never more than 6, because number of Z's may complicate the governing. So working is whenever, if you see this, whenever you with the help of anvil you rotate, the water from the construction moves through the veins, and the bucket starts and the runner wheel starts rotating, where the shaft wheel is connected to this. So with this shaft wheel connected, we can generate the electricity, which is coupled to the generator. So the advantages of Pelton wheel are, it operates at very flat efficiency curve. It operates at high head low discharge. It is very easy to assemble, and there is no cavitation of chances. It has very few parts when compared to Francis turbine. It is applied with both first and second law of motions. So these are the some few advantages of Pelton wheel, and every item every component in this world is having some disadvantages. The efficiency decreases with respect to time is very high, and the turbine size generator powerhouse required is very high. And the application of Pelton wheel is preferred turbine of hydropower, where the water available source is high, hydraulic heads are low flow rates. Now we go to the efficiencies of the turbine. First is hydraulic efficiency. It is defined as the ratio of power developed by the runner to the power supplied to the inlet of turbine. And the power supplied to the inlet of turbine is, we are giving the head of the water based upon the discharge. So it is rho g QH. There may be a losses of heads, so it will be taken gross head minus frictional head losses. And next is mechanical efficiency, is nothing but power available at the turbine shaft to the power developed by the runner. How much power is generating when it is rotating with the help of runner wheel rotation. So P by power developed. And the volumetric efficiency is quantity of, it is defined as the ratio of quantity of water actually striking the runner with respect to quantity of water supplied to the turbine. And the overall efficiency is defined as the ratio of power available at the turbine shaft to the power supplied to the turbine inlet. And the specific speed of the Pelton turbine is taken as N root P by root P into GH H power 5 by 4. And the flow ratio is generally taken as V1 is equal to CV root over 2GH. And for the speed ratio, KU is equal to U by 2GH. And the value will be 0.2 to 0.4 to 0.6, whereas C will be 0.96 to 0.98. So these are some important questions which are asked in your university examinations. Thank you.